Hi everybody, how are you all? Hope you doing great. Welcome back to another session of learning physics with me. Before beginning, I would like to request please subscribe the channel Tangent Academy. Also like the video and share it with friends too, because you will get one either physics problem or maths problem every day. Now, let's begin with today's session with the topic unit and dimension. As in the previous session, I discussed about the unit, their nature, derived unit, particularly in detail. In this session, I will discuss about the dimension and some numerical problems concerning to it. Let's begin with all the physical quantities represented by derived unit can be expressed in terms of some combination of seven fundamental units or base unit or base quantities. The seven quantities treated as seven dimension in physical world, which are denoted with square bracket. Suppose these are as follow: length is denoted by under capital bracket L. Length is denoted by L. Mass is denoted by M. And time is denoted by capital T under capital bracket. Electric current is denoted by ampere, capital A, which is symbolized as capital A. Temperature or thermodynamic temperature. Temperature, you can write this memorandum. Temperature can be denoted by K. K is denoted as Kelvin is the measurement of one of the five temperature. Measurement of temperature can be measured by 5 units. One of them is Kelvin. So temperature is denoted by K. Luminous intensity is denoted by CD. Luminous intensity, prakashiya tivrata. Luminous intensity is denoted by CD, which is known as candela, and so on. Now, we say that in mechanics, all the physical quantities can be written in terms of base quantities, either L or M or T. For example, area. What do you mean? Length into length. Length square, whose dimensional formula is written as capital bracketed under L square, which is finally written as M0 L square T0. What do you mean? It means the area has 0 dimension in mass, 0 dimension in time, and 2 dimension in length. Area has 0 dimension in mass, you can write 0 dimension in time and 2 dimension in length and 2 dimension in length. One another example, let us take volume. This means length into length into length. So it gives length cube. Dimensionally it can be written as m0 l cube t0. It means the volume has 0 dimension in mass, 0 dimension in time and 3 dimension in length. Now we are wishing to define dimensional formula, the expression which show how and which of the base quantities represent dimension of a physical quantity, called the dimensional formula of the given physical quantity. Let us take some example. Area. Area is given by m0 L square T0. This is dimensional formula of area. Volume. m0 L cube T0. This is dimensional formula of volume. Velocity. You can derive by observing its formula also. Velocity is meter per second. So it can be written as m0 L1 and t minus 1. That is, velocity has 0 dimension in mass, 1 dimension in length and minus 1 dimension in time. Let us take force. Force is nothing but kg meter per second square. Its SI unit is kg meter per second square, which is known as Newton. So force is kg meter per second square. Kg means it has dimension 1 in mass. Meter, it has 1 dimension in length. Per second square, it has minus 2 dimension in time. Similarly, pressure. Pressure can be redefined as force divided by area. Force can be changed fundamentally. Kg meter per second square divided by area can be defined in meter square. 1 meter and this power has cancelled. So it can be rewritten kg per meter per second square. Therefore, dimension of pressure, dimensional formula of pressure, dimensional formula of pressure can be written as 1 dimension in mass, kg, 1 dimension in mass, 1 dimension in length and minus 2 dimension in time, and so on. In this way, we can convert all the physical quantity into base quantity, mass, length, time by giving its power, by raising its power, how much dimension that physical quantity has. And in this way we can explain. Remember that now we will define dimensional equation. An equation is obtained by equating physical quantity with its dimensional formula is called the dimension equation. Again listen, an equation is obtained by equating a physical quantity with dimensional formula is called the dimensional equation. Suppose dimensional equations, these are the dimensional equations which are going to be written in the board. Dimensional equation. For the velocity, capital bracket under bracketed is equal to, while equating, as I have explained earlier, while equating to its dimensional formula, then it will be an equation. It will be an equation. So velocity, as I have seen earlier, velocity m0 l1 t minus 1, m0 l1 t minus 1. Velocity, force, capital bracketed capital F, force, equating to its dimensional formula, force is m1 l1 t minus 2, m1 l1 t minus 2. As these symbols are equated to something else, therefore these are the equations. Similarly, volume, capital V, here I symbolize as capital V, and velocity for small v. Here I can see m0 l cube t0, m0 l cube t0. In this way, we can write dimensional formula of all the physical quantities. Now, very important thing, notable thing, only those quantities can be added or subtracted which have the same dimensions. Again listen, only those quantities can be added or subtracted which have the same dimensions. Dimensional analysis. Now I wish to discuss about dimensional analysis. It is found that dimensional analysis help us in deducing certain relation among the different physical quantities. Also, it helps us checking the derivation of physical quantities. Also, accuracy and dimensional consistency of the various mathematical expression. Now we will see it, we will observe it, we will discuss it by some of the example. Dimensionally, how to check whether a given equation is correct or not. Let us take the dimensional consistency. Check the dimensional consistency. Now you can write this question, check the dimensional consistency. Check the dimensional consistency of the formula. Distance S is equal to S naught, that is distance at initial position. S naught. S is equal to S naught plus V naught T plus half a T square plus V naught T plus half a T square. This is the equation of the physical quantities for distance. Now we have to check whether this equation is dimensionally correct or not. How it be possible? If every term according to, as I have told you before, only those quantities can be added or subtracted which have the same dimension. So each term should have the same dimension. S naught, V naught T or half a T square, and also in left hand side S, it should be same dimension. So first of all I am taking left hand side. Left hand side is S. S is distance. Distance can be dimensionally written as capital bracketed L. This is left hand side. S naught, from right hand side we will write further. S naught is also distance, so its dimension will be L. V naught T, V naught T initial velocity into time. Velocity is velocity, so this has dimension Lt minus 1 and time for T1. These are cancelled. So T, according to law of indices, Lt0, it can be written as L. So second term V naught T is also has dimension L. Now we observe half a T square, half a T square. Here variable are acceleration and time. So acceleration is nothing but Lt minus 2 and here power is 2. Time, for the time are cancelled, so it yields as L. We observe that each term of the RHS is also has dimension L. So dimensionally, therefore dimensionally given equation is correct. Dimensionally given equation is correct. Now I wish to take a very important derivation for the time period of simple pendulum by using dimensional formula. I am going to derive time period of a simple pendulum. T is equal to 2 pi under root L by G. These are the application of dimensions. Please let us observe. Proceed ahead, we have to derive T is equal to 2 pi under root L by G. You know that what is simple pendulum? Tensionless string. This is a bob of mass m. Bob of mass m. The weight of the string is supposed to be negligible. Now, the dependence of time period of a simple pendulum are as follows. This is the length of the bob from the fixed point. We know that this simple pendulum do simple harmonic motion and directly proportional to towards amplitude is directly proportional to towards the center. Negative times. We already know that this is not my discussion concern. I am going to evaluate time period of this simple pendulum is 2 pi under root L by G where L length of string, G gravitational acceleration, G is gravitational acceleration. Let us consider we have to use three dimensions as mass, length and time. So let the dimension of mass, length and time are x, y and z. Let us consider the dependence of time period. We know that the dependence of time period is directly proportional to the length of the string. The time period is directly proportional to the length of the string. That is, as length of string increases, the time period will be increases. The dependence of time period is directly proportional to length of the string. Also, time period is directly proportional to gravitational acceleration. Gravitational acceleration. And mass of the body. And mass of the body. It means, it implies time period is directly proportional to L to the power x. As I have suppose dimension is x. Secondly, time period is directly proportional to g to the power y. And third, time period is directly proportional to another mass, no? M by G, T is equal to under root L by Z. So mass is not happening here, independent of from mass. The time period of the body is independent of mass. Combining these two, time period is directly proportional to m to the power z. I have supposed m to the power z. T is directly proportional to L to the power x into g to the power y into m to the power z. By removing this proportionality sign, we get T is equal to k times Lx gy mz. Let us continue. Where A is dimensionless constant, taking dimension both sides. Now we will take dimension both sides of this equation. Taking dimension on both sides, taking dimensions on both sides. Here we can see left hand side, in the left hand side T, time period. For the time we can write dimension as L0, M0, T1. Time has 0 dimension in mass, 0 dimension in length and 1 dimension in time. This is in left hand side. This is happening in left hand side, where in right hand side k times length has 1 dimension, 0 dimension in mass, 1 dimension in length and 0 dimension in time, and length has power x into, this is g. G means acceleration, meter per second square, lt minus 2. L, it can be written as mass has 0 dimension, length has 1 dimension and time has minus 2 dimension, to the power y into mass. Mass has 1 dimension and 0 dimension in length and 0 dimension in time. So write it down. Mass has 1 dimension is m, 0 dimension in length and 0 dimension in time, to the power z. Arranging this power on left k times power to the power 0 L to the power x plus y. Here L has power, L to the power x, L to the power y. and 0 is cancelled, so we can write L to the power x plus y into L to the power x plus y, t to the power minus 2y. Here minus 2y. Here t has 0 power. Here t has 0 power. So this power will be multiplied by this power minus 2y, t to the power minus 2y. So time has minus 2y power, and third one is m to the power z. Only one dimension in m, so m to the power z. Now operate this left hand side, m0, L0, t half. Equating this power, here length has x plus y dimension, and in right hand left hand side length has 0 dimension. So equating powers of like terms, equating powers of like terms. Here L power x plus y, and in the left hand side L has 0 power, so I have equated it to 0. So we can write it y is equal to minus x. Y is equal to minus x. Here t has power minus 2y, here t has power 1. So minus 2y is equal to 1. Therefore y is equal to minus half. Here z, m to the power z, यहाँ m to the power 0. So z is equal to 0. That is z is equal to 0. Now putting y in this, y is equal to minus half is equal to minus x. Therefore x is equal to half. So we have got x is equal to half, y is equal to minus half, and z is equal to 0. Now we will put this power so our concluded result will be time period is equal to k times L by G. Which has power L? L has power 0. L to the power half into G to the power minus half. It can be rewritten k into L to the power half divided by G to the power minus half. Half. Because according to law of indices, this power can be written in positive in denominator as follow. So these all have half power. So time period, therefore time period t will be k times L by G whole power half, which is t is equal to k times under root L by G, where k is dimensionless constant, where k is dimensionless very carefully. This is the derived form. The derived formula t is equal to 2 pi dimension which is taken as taken as 2 pi. This dimensionless constant is taken as 2 pi. It should be noted very carefully that here mass has power 0. So, very important thing is the time period of a simple pendulum is independent of its mass. Either it is 5 kg or 100 kg or 2000 ton, it doesn't matter. Time period is always independent of mass of the bob. And we have got the required result as t is equal to k times under root L by g, and which k is dimensionless constant, and taken it as a 2 pi. Thank you for watching. So I hope that this video will be helpful for you. Like it, share it. I will meet you with a new video next day. Till then, take care and bye.